Great. We had some technical difficulties, but everything seems to be set now. So our next speaker is Merve Noyan, building Python data apps using Gradio. The floor is yours.
Thank you. Does it work? Does this work? Yeah, it works. Thank you. Hello again, and welcome to this talk on building data and machine learning applications in Python. I'm Merve, and I'm a former machine learning engineer, now a developer advocacy engineer at Hugging Face, which is essentially about developing open source and talking in beautiful European capitals. I'm also doing research in natural language processing, and yeah, like I mostly do open source stuff. So today's talk it hits hard, hits at home. When I was a machine learning engineer in relatively small startups, you know it, like you do 3 people's job. I would take the data, clean it, do exploratory data analysis, and then build a model and build a demo based on it, if not deployment. And it was really hard, like so basically I met data science when I was in undergraduate in a data science class. I fell in love with it. Like it was so funny, first application I built was some sentiment analysis on Twitter with R. And then I met Python and I was like, I'm going to make this my job. And then it happened until I met building stuff with Flask and Docker and deploying them. It's a harsh reality of being a full stack machine learning engineer in a small startup. So I would like essentially as a machine learning engineer or a data scientist, you should be focusing on the data and what you are building with it and not the programming part, because I would say most of the people are coming from non-software engineering backgrounds. It's a very welcoming field. And I was like, why do I have to deal with all of this? Like, it doesn't even look good. Like, I would have to write CSS, JavaScript, Flask, and at the end, like, I would spend hours and it wouldn't even look good. And nowadays, it's possible. And nowadays, you can build applications like this, and it's completely written in Python. I didn't use anything, and I didn't even use anything for the deployment as well. I will show you how you can build neat UIs for your data or machine learning applications with very few lines of Python code. And this UI was made possible thanks to Streamlit and Gradio. Otherwise, I wouldn't be able to build that. And no, I didn't want to deal with, HTML, Svelte, or JavaScript. Like, no way. And like, you cannot believe it, but like, you might have seen the UI of Stable Diffusion yesterday, and also DALI Mini, which went viral back then, and it's all made in Python with Gradio. This is an example of DALI Mini where I would prompt a Lovecraft monster in pastel colors. And what is possible? So you can build data applications, machine learning applications, data dashboards with support of Plotly or Matplotlib and more. But essentially, Gradio was made for machine learning rather than building data applications. That's why it's very practical in mostly machine learning. But now you can also use it for data applications. So you can, for instance, build a video classifier app, text analysis app. So these components are all made by the team at Gradio and also the open source contributors. And for instance, this is an application that does named entity recognition, part of speech tagging, and showing the parts of speech. You can build UIs for your predictive models, like you can have a CSV file, a data frame, and then you can put a machine learning model in the background and make predictions. Like I was thinking, like I was a machine learning engineer. I was building sales prediction applications, NLP applications like question answering, information retrieval, or chatbots. I was like, where was this when I was a machine learning engineer? And you can also build audio. You can even build like 3D based applications nowadays. And essentially, these UIs are all a class called interface. And this interface is built with input components, output components, and the function that runs in the background that does the inference for your machine learning model, or if you want if you want to process the data, like whatever you want it to do. You can instantiate the interface with these and then call the interface with the input and get your output. And I'm going to show you how to do this quickly. So in here, I built a very deterministic and dummy image classifier that assumes every image is always 70% dog and 30% cat. So this is my function that I previously mentioned. And I'm instantiating interface with my function, the input type, which is an image, because it's going to classify an image, and output type is labels, which is dog or cat, and their probabilities. And then I call launch. And here is my cat classified 70% as a dog. As you can see, I have my image input, my label output with the probabilities. And you can even customize it, like you can add a title, a description, you can add examples, which is very good to hint your users what to input and what not to input. So in here, I'm giving example, my cat and my dog's image. You can pass, for instance, for images, you can pass some a JPEG file path. For CSV files, you can just pass CSV files if you have a data frame and so on. And then later, I just pass them into my interface. And it looks like this. This is my dog. And you can see over there, I have a description called a simple dummy image classifier, a title called dog or cat classifier, and my examples that user can directly click into without, dragging and dropping a new image. And if you want more flexibility, we have an API called blocks to give you that. I will not cover this in this talk because it's more complicated than the interface, but you can check it out. And for instance, I made this app that is a baseline trainer. It's like a cheap version of the auto train that you have learned yesterday that has this library called Data Analysis Baseline Library that basically tries so many classifiers in the background and shows you the best one. So this application, you can either train a model or analyze your data. It has 2 tabs, and you enter your CSV data set. If you are going to train a classifier, enter your target variable and then your Hugging Face token, and it's going to push the best model to your profile. And this was made possible thanks to blocks, basically. A cool thing is, yesterday you saw the pipeline function by transformers, right? So every model with a task tag, for instance, like yesterday you saw that model repositories have like tasks associated with them. It can be image classification, it can be text generation, it can be anything that Hugging Face accepts. And every model that the library has the integration with, and the task tag gets the inference API that you saw yesterday that Julian was typing into. And this is leveraged by Gradio as well to easily build interfaces with only 1 line of code. And this is crazy. Like, for instance, this is a question answering application. that takes a context text that you want to ask your questions to, and it takes a question and then returns the answer with the probability. And it has its example. And what I just did was Gradio, I called the interface load, which says, hey, load the model from Hugging Face Hub. And because the model is over there with the associated tag, the Gradio knows what type of input and output that the interface expects. So it can simply build this application with that. And this is a transformers model, and transformers has an integration with Gradio. And recently, I started developing this scikit-learn package with two awesome developers that is going to hopefully solve the production problems of scikit-learn, like secure serialization or model cars reproducibility. And it's called SKOps. And SKOps also has a integration. In fact, many libraries have integrations, but I just wanted to show this since this is my baby. And essentially, it's because the features are not universal in tabular workflows, it expects some features as like attribute 0, attribute 1, and so on. SKOps, when you serialize a model and push it to Hub with SKOps, it pushes an example input with the feature names and stuff so that Gradio knows what to expect. And again, it just builds the interface with only one line of code. And deploying this is even easier. So these UIs can run on your local, they can run on Colab, in Jupyter notebooks, but if you would like everyone else to see this without, I don't know, giving them some redirection to your local NG-ROC setup, you can deploy it to Hugging Face Spaces, which is completely free. And it's where so many applications are, where people host their applications. There are academicians that host the output of their papers. There are students that are hosting their homeworks. There's people like me that hosts their portfolio. It's really cool because, like, for instance, when you get recruited, people do not really spend that much time on your GitHub repository, so it's a good way to say, hey, I can actually build this app. And so many people are also like hosting their cool UIs like Stable Diffusion or DALI Mini that you might have seen recently. And essentially, you don't even have to only deploy Streamlit or Gradio. We also accept static. Soon, hopefully, we will accept Dockerfile and more. Like, for instance, this is made by my colleague. It's a game based on reinforcement learning agents called Snowball Fight. And it's hosted in Spaces. And for instance, this is Stable Diffusion in painting, in which you just paint over an image and then say, hey, please replace this painted part with an object. Like I said, Baby Yoda outfit, and it gave me this on my cat. I think she's rocking it. You can just go over there, have fun, or build an application like this and show it to the world. Another cool one is, again, built by my colleague. This is a conversation with Gandalf, and basically you can ask questions to it, and it answers as if the chatbot is the Gandalf. And this is also built with Gradio. You have your slider inputs, you have your message, and these slider inputs are controlling hyperparameters of the text generation. And the message is the question that you want to ask to Gandalf, and then you have chatbot outputs, as you can see. And getting started is also super easy. You just need to go to Hugging Face Hub, go add spaces, pick a name for your space, and then an SDK for your space, which can be Streamlit, Gradio, or static. and then simply drag and drop your application file. These are essentially Git repositories, and you just write your application file as I have shown you, and it's just built. And I can show you a demo today. So if you have any questions, we have a Discord, and now off to the a little bit hands-on part, but maybe before that I can have some questions. No? Ah, okay. I think it's good for other people to hear.
Yeah, no, I was like, otherwise you repeat it back. So you were showing Streamlit and Gradio. So I was just curious about when would you use Streamlit, when would you use Gradio, and how do they interact? Like, can you build, together?
That's a good question. Thank you. So essentially, I feel like the philosophy behind Streamlit is mostly data applications, and Streamlit is about stacking components in a very sequential manner rather than having one interface and passing stuff over there. So if you want good flexibility with very easy building, you can opt for Streamlit. But if you want to build something about machine learning, the components of Gradio is more accepting of different file types, for instance, or specialized for machine learning. So I would recommend that. Also, Streamlit has, I'm going to show you. Let's do this. Streamlit. Cool thing about Streamlit is, so it has many community components. For instance, like it has a spacey component. It has stuff specified for molecular stuff. It has a GINA component for neural search. Like there is non-pandas profiling, which is one of my favorite applications, honestly. Yeah, here is the spacey component. So it has many community components that you can use, like WebRTC. But to my observation, for instance, like for WebRTC, if I'm going to give an example, Gradio has everything built in, and it requires less effort to build something that takes a microphone or camera input compared to this, because this is a third-party component. So I would suggest you, if you are going to do something fancy, maybe opt for Gradio, but if it's something basic and you want flexibility, use Streamlit. And also, I want to show you the components of Gradio. It's a bit like Django and Flask, where in Flask you get yourself everything, and in Django, like you have like everything built in. It's a bit like that, I would say. So, yeah. So in Gradio, as you can see, you can have text box, slider, checkboxes, data frame, time series, highlighted text, 3D model, chatbot, plotting. For instance, this supports anything with matplotlib and plotly, and more. So it's cool. So let's do a hands-on thing. So I previously built this, but I would like to first show you how to build a Hugging Face space. So let's go to my profile first. Oh, sorry. So you go, click New Space, and let's say, like you can give a name to your space. I love Stockholm. And you can pick a license, so in case like people try to commercialize your space, like it prevents that. I usually pick Apache 2.0, and you can pick your SDK, and you can also, if you want it to be private, you can make it private or public. So I choose to make it public. And my space has two things. One is the README file, and one is Git attributes, but I need my application file for the space to work. So, and it's called app.py. And I already have built something. So, and it's a story generation application. And the cool thing is, I built it with the interface.load. Just a second. Let me walk you through this application. So I have the description. Can you see it? Can you see this font? Is it okay? So I have a description. I'm loading the interface. So reason why I defined my input was that I wanted it to have like longer input. So there is like two components. One is text and the one is text box. You can also customize anything that you are loading the model from. It's okay. So, and like you can give it a label. And then I have given it an example. These examples are list of lists usually of for each inner list being an example, like a single example. And that's it. And just a second, and I can input anything. Adventure is approached by, so basically this is an application that is sort of trained on the Dungeons and Dragons type of data. Let's see. I didn't open it for a long while, so hopefully it still works. And this, by default, this runs on CPU. We recently introduced hardware customization, so you can actually get better hardware if you want to, or like, for instance, you have a very cool application. We grant you hardware, like extra better hardware if your application is really cool and you think that there is a lot of demand for it, that there is a lot of queue and the processing time is long. But you can also, like, if you want, you can also pay for the hardware if you want to, but essentially this works on CPUs, and CPUs are okay-ish for inference for most of the time, except if it's like a stable diffusion model where there is like 300 people waiting in the queue. So output is, adventure is approached by a mysterious stranger in Tavern for a new quest which may cure his friend's terminal illness, which doesn't really sound like Dungeons and Dragons, but okay. It's usually about the, you know, like there's a monster in this village. Can you please kill it? I will give you a lot. Yeah. And that's it for my talk. I can have questions if you have any. Thank you. Just in time.
Thank you very much for this very interesting presentation.
Thank
Indeed,
you.
a simple way to create some nice interfaces. We have time for perhaps one question.
No?
No?
Cool. Thank you so much.
Yeah, thank you. And thank you for keeping the time. So we are back on track now. So we will take a lunch break now. Lunch will be served in the same place as yesterday. So the end of the corridor, down on floor. And we will be back here at 1 o'clock.